Good day and welcome to this tutorial on basic plotting using Python, using the Matplotlib module in Python. So the objective of this tutorial would be to understand the structure of plotting in Python, to understand what inputs are required for a plot, and to familiarize oneself with labeling plots and adding some legends. So first of all, we start off by defining the plot function. To first of all import matplotlib.pyplot as plt, which is the mathematics plotting library. Also, I would be using a function in NumPy later, so I import NumPy as np, and I also use the percentage matplotlib inline to plot in Jupyter. If you are using Spider, you can neglect this and just use the code. So first of all, we can plot data points. First of all, I'm going to show you the default in how Python plots data. So first of all, I'm going to generate some random points from 0 to 5. 0, 1, 2, 3, 4, 5, and some random y points 1, 5, 6, 2, 3, and 4. So to plot in Python, you start off with plt.figure. Then you use the plot function in pyplot with the x, y data, and then you end off with plt.show. So let's run this and see what we'll be getting out. Okay, so here we can see that Python automatically connects the data points corresponding. So 0, 1, 1, 5, 2, 6, 3, 2, 4, 3, and 5, 4. If we want to use a scatter plot, here in the plot we can specify adding a string, so a blue line, and we want a star symbol. So here we can plot the dots. So here we can see the data points. If we want to go ahead and plot some continuous functions, maybe f1 equals x, f2 equals x squared, f3 equals x to the third. Here I'm gonna generate some data points between -1 and 1. So I'm gonna use the function linspace between 1 and 1, and I'm gonna use 100 data points. And for the corresponding functions, I'm just gonna get the x squared, and x to the third. Should be -1. And here I have my data set. So here I can also go ahead and use the structure here. Let's take that out. It's going to be continuous functions. So here would be x, f1, run that. So here we can see that f1 the straight line, f2 the quadratic, and f3 the third power curve. We could also specify the line type with some line definitions with the following format. So we add them as string characters, like I did here at the start to create some scatter points, and here we can also add dashed lines, dotted lines, circled marked lines, and you can go through the description and which character would be going with that. Also, we could specify the color. If you need this definition, you can just go on the plot function in the help file. So if you go to the help, you would see that the character list is also in here, if you would need that as a reference. So just to show that this actually works, I'll copy that, maybe add a dashed line, a blue dashed line for function 1. Green line with circled marks, and a red line with triangular markers. Short of comma. Okay, so here we can see the 100 data points now with circled and triangular and dashed lines. Further on, we would like to end up in labeling the Y and the X axis, as well as adding a title. So for that, we're going to use these functions. So to add the titles, we add the following command. So plt.xlabel, plt.ylabel, and plt.title. So here we can just add the string values. So usually we plot something against time, so maybe we want to plot something against time. So here we can add it in seconds. Note the dollar markers give a mathematical text output, and here for Y we can just add Y title, and for title we can just add main title as an example. Let's run that. Here you can see time in seconds, Y title, and the main title. We could also go ahead and change the font size of this, so maybe font size equals 16. Run that. Here we can see that the title actually got bigger, and we could change that also for the X and the Y labels. In some instances we would like to add some mathematical text. So here are some known Greek alphabet letters that I know of. You could go through this list, maybe alpha, beta, gamma. So just to show how this works, maybe if you want to add sigma, maybe in the main title you can go here, $2 for the mathematical text and the sigma sign. Let's run that. and there's the sigma sign. So you can, if you want to add mathematical equations, you can add that in there. Then the final thing I want to show is the addition of the legend. So I'm gonna go ahead and copy this. So adding the legend, we can do it in two ways. So let's make those continuous functions now. We could add it in here with label equals, in this instance, text blue line. We can go ahead, copy that for speed. Here we can go green, red. And to end off with this, we add the function plt dot legend. And here we can see the corresponding titles to our lines. Also note that in this text we can also add mathematical text. The second way we can add the legend is with a legend list. So here we can maybe define a leg list equals list where we input that. Yeah, we can erase and in legend we can just add leg list and run that, and here we can see we generate the same results. Furthermore, maybe we would like to shift the legend list. So if you go into the help for the legend, you would see here we can define a location with the location code 0 being best, upper right, upper left, and so on. So I usually use 0 because for the curve it generates the legend away from the curve. So in this instance we can add for the legend location equals 0, run that, and you would see it generates the legend away from the graphs. Thanks for watching. I hope you found this insightful, and like this video if you want. Enjoy your day.